As the mining industry embraces the benefits of data driven mining, fast and dependable on site connectivity becomes essential for improving both safety and productivity. Ian Ross, Ericsson Head of Enterprise Private Networks, Australia and New Zealand, joins us to discuss how on site private 5G network connectivity is allowing miners to innovate with new ways of working. Ian, when people think about mining, they maybe think it's all about heavy machinery, but what's the concept of data driven mining?
Yes, Adam, at data-driven mining, it's a practice of using data, analytics, and machine learning to guide decisions and operations within a mining context. So it really just allows better decisions to be made in real time. And the reason it's so prevalent is that everything is data-driven mining now. Existing practices like mine planning and operations and fleet, but it also extends to future initiatives like clean tech adoption and electrification. It's a very, very broad topic that is really driving the future of mining is around the advancement in safety and smart mining practices.
And of course, if you want data from a mine site, then you need connectivity, and that obviously presents challenges. What were the benefits from moving from using Wi Fi on site to 4G?
Yeah, so the transition from Wi-Fi to 4G is largely being fueled by the needs of data-driven mining, and you could almost say it's also driving the same way in reverse that it's being driven by data-driven mining, but also enabling data-driven mining. And the fundamentals here are that Wi-Fi has been a great technology, but mining largely encompasses large areas and outdoors. And in mining, you might see many trailers holding Wi-Fi access points that need to be moved around and repositioned based on blasting. And then underground, you might have many twists and turns in a underground complex that makes deploying a Wi-Fi network particularly difficult. Wi-Fi as a technology is good for IT, but when you start looking at operations technology, like in the mining space, out in the mining zone, or we have multiple applications running, what we see is Wi-Fi has connection stability issues with how it operates. As these networks grow, as more load is put on them, they slow down, they become unpredictable, and that's a real problem. If you look at automation and robotics, that these applications have latency requirements, they have packet loss thresholds that, if triggered, start safety and protection mechanisms. So it's really important here in mining, and what's driving that transition from Wi-Fi to 4G is to provide a form of wireless connectivity to connect mobile assets, but that connectivity is suited to automation, robotics, and stable, high reliability communications, but can be done so over a broad area. These mine sites aren't a small warehouse in the middle of suburbia. They're kilometers wide, they're hundreds of meters deep in some places. So they're very large areas to cover, and we need that seamless mobility and that deterministic performance to make the future mining applications run.
And of course, when we say 4G for a mining site, we're not talking about relying on the nearby mobile towers, are we?
No, no, these what we're talking about are private cellular networks. So these are networks that are owned and operated by the mining house. They're built and designed to specification, and they are their own mobile network. They have their own network equipment in the middle. They have their own radios on towers. They even have their own SIM cards that are programmed with their own network codes and unique encryption keys. So only the mining company's devices can connect to their network and no one else's. And they operate in complete independence of any carrier network that is in that area, if there is a network in that area at all.
Hmm.
Many of these networks deployed in areas where there is no connectivity because there is no population.
So the moving from Wi-Fi to 4G, you can see the clear advantages there. So what difference does 5G make?
Yeah, so when we think about 5G, a lot of us think about it in a consumer lens. We read what's in the media that it's a wireless technology that's going to be 10 to 100 times faster. It's going to support thousands of more devices. It's going to be more responsive. It's going to be energy efficient. But in the mining space, what 5G allows us to do is to access more spectrum, radio spectrum that's necessary for wireless networks than has been available with 4G. So it's a leap forward in terms of the size of the networks and where you can build these networks. The technology itself has what's called greater uplink efficiency, which means higher upload speeds. And this is really important for mining because the machines and systems we're connecting are pushing more data into the network than they're taking out of the network, which is the opposite than we get as consumers, where we're downloading content, movies and video and emails, and not really pushing much back into the network. The other thing that 5G brings is what are new radio technologies. So this new equipment, these new technologies provide extended range. So back to the question before around Wi-Fi and the benefits of moving to cellular from Wi-Fi, it's all about very large sites where broad coverage is critical. 5G allows us to cover broader spaces with less equipment. And then ultimately, there's also energy efficiency improvements. One of the big things that is driving 5G technology development is reducing the power consumption of wireless networks. Really important for a carrier, but just as important for a mining company where these sites are remote powered or solar powered. So lower power budgets for 5G, particularly for those solar sites. There's low latencies as well. So as we look at human machine interfaces like remote control or sensors that need really high speed event correlation, for example, seismic or ground movement, those lower latencies, that responsiveness of 5G is critical to enable those applications. Then finally, there's technology progression. 5G is the evolution of 4G, and like everything that comes after the predecessor, except for some movie sequels, it's generally better, it's more modern, it's smaller, lighter, faster, smarter. So that's really what the difference 5G makes.
So it's obvious how the move from 4G to 5G would benefit existing processes, but it also opens up a range of new options, particularly in terms of things like sensors that just weren't as effective or as feasible on 4G. Can you tell me a bit about that?
Yeah, so when you think about the mining space, a lot of the focus around wireless adoption has been around improving existing operating models.
Hmm.
How to take haulage and make it smarter or automated, how to deploy automated drilling systems, how to have remote control earth moving. But a lot of the power of 5G is innovating ways of working and new ways of working. And this is fundamentally enabled by the fact that 5G gives a stable, high performance connectivity that can be anywhere. And a good example of this with rock bolts and sensors is what we've been doing with a Swedish company called ThingWave around digital ground support for underground mining. And in the underground mining space, you do have rock bolts that are drilled and screwed into the side of mining drives to help shore up the rock face that's being worked on. But with smart rock bolts, what we're actually doing is putting a sensor on the end of those bolts that take data in real time and can transmit to a gateway and then feed a digital twin that allows visualization of that data. So what we have now is a rock bolt that is able to detect and report rupture or due to shear or elongation. It can capture the stress and the strain and transmit that data over the network. And it gives geotechnical engineers the ability to remotely view the status of their bolts from the safety of the surface. So they don't need to mobilize themselves underground into a higher risk mining environment to capture the status of rock bolts, either they're broken or how they moved. That data is being transmitted to them in real time to a digital twin that they can access from the safety of their desk. So what it gives us is that real world deformation data that's now going to be available in real time to the people that need it without putting them in any high level of risk to obtain that information.
So there's the dual benefit there. It lets them do more and see more. Like you said, there's a real time
Yep.
replica of the mine that they can see with, maybe thousands of points, but also doing all that more safely because you don't have to stand next to the rock bolt to see what's happening.
Well, exactly. And I think when you look at this is a scale problem. So the idea of monitoring ground movement with instruments is not new, but these instruments have been expensive and complex to deploy. That means that there's been limited deployment in underground complexes because of the cost. It also means there's limited scope of measurement. But now what we have with rock bolts with sensors is a low cost system that can scale. We're talking thousands of sensors. They can be deployed with regular teams, and it gives thousands of data points that geotechnical engineers can now monitor. Now, this is the interesting with 5G. These rock bolts leverage 5G's scale and performance. We can move from measuring point displacement to whole drive movement. And that's because when you have thousands of these sensors, they all need to be connected and they all need to transmit at once. This requires wireless because you can't run cable everywhere to these sensors, but also requires scale, low latency, and connectivity everywhere. So what 5G is enabling with these sensors is, yes, we're introducing a new level of operation visibility around safety, particularly with ground stability and mine movement. But we want to also monitor rock falls. We can improve drilling efficiency, but the sensors can also detect air quality. So even after a blast, the all clear and the return to work can be much faster than it has been traditionally, which is a huge productivity benefit. So with all of this together, 5G now gives us the ability to connect the heavy machines that everyone associates with mining, but we can use that exact same network to connect cameras, process control systems, sensor systems, smart rock bolts, as well as personal communications with staff. So 5G's impact in the mining space is significant with how it can be used to drive new ways of working and innovation.
That example of being able to say more quickly and with more confidence, yes, it's safe to go back, is a good example of a benefit that you might not think of at first. It's like, okay, I can see a better view of the mine. That's great. But it's a good example of how it lets you do new things. Are there other opportunities, benefits you've seen that the mining industry has found that just wasn't feasible with the way they were doing things previously?
I have a great story, Adam, I'd love to share with you. And this is what a mining company, Newmont, they're the world's largest gold miner, is actually doing at their Cadia mine in New South Wales. So they had an issue at site where their tailing storage facility, so where they store the water and the sludge from the gold extraction process is stored, their tailings facility suffered a loss of containment back in 2018. Basically, there was some seismic movement. The dam wall it experienced what's called a slump, and there was loss of containment into the basin of the secondary tailings facility. So it was all fine from a safety perspective. The safety plans were triggered, so there was no injury or loss of life, which is the primary focus in the mining sector. But when it came to remediation, what it required was that dam wall, which is like a 4 kilometre long, 90-metre high structure, need to be remediated and need to be remediated with 8.5 million cubic meters of earth. Now, that's a big number.
Hmm.
And I always wondered, well, how do you envisage what 8.5 million cubic meters is? So that's enough earth to fill the MCG to the roof, to the top of the stands, 6 times over. And that amount of earth had to be shifted in a short space of time in front of the dam wall. But the conundrum for site was that work was in a high risk area. They're working on a wall that has collapsed. And the Australian Council of Large Dams safety standards actually specified for that level of work, the factor of safety was too low to put staff in the cabs of machinery like bulldozers and trucks. So what site saw was they'll have to use remote control equipment. That is, they had their staff operating these large 110-ton dozers from the safety of a remote control chair, a bit like your Formula One race seat, but it's dealing with a much slower bulldozer, away from the high risk area of the mine site. So they're controlling these massive machines remotely with joysticks and screens. But the issue was the number of machines they needed to deploy to meet the timelines of the project meant that the capabilities of the existing Wi-Fi network at site were exceeded. These machines required performance around 6.5 megabits per second uplink. So upload into the network, sustained, multiple machines, multiple cameras. They would stop if there was more than 2 packets lost per second. They required less than 50 millisecond latency for a response. So when you look at what they were looking at, with 16 machines in their forecast, 64 cameras, they need a network that could actually support 132 megabits per second of sustained data transfer for all the video streams for the remote control. Except the Wi-Fi can't do that. Newmont put a third dozer on the Wi-Fi network and the whole thing broke. all the dozers are inoperable. The most they could run was 2, and they needed 16. They couldn't use 4G because the capacity wasn't there. They couldn't use other technologies, so 5G was the only answer. So with that, they were able to deploy a 5G network to really bridge the gap to what other technologies could do. And with that, they were able to light up the entire work zone of the mine site. They were able to connect dozers reliably wherever they were deployed, and they were able to generate significant productivity savings to keep the project on track. So, for example, turning the network on, they were able to experience a 50% increase in the push capacity of the dozers. They were able to shift over 25% material per shift. And as one of the operators said, they spent more time pushing earth, not chasing signal. And the reason why that was significant is where they came from with Wi-Fi actually caused them a range of performance issues. This is amazing, but they actually found that there were problems that they experienced where they lost line of sight between the equipment and the network with Wi-Fi, minor obstructions, other equipment in the way, rock bonds, change the angle of the equipment, everything would drop out. The network would become unreliable in different weather conditions. It doesn't make any sense. But rain, wind, even cloud degrade the signal stability. There were random black holes, and sometimes these outages could take the team 6 hours to troubleshoot. So you imagine if you're on site to do a job and you're spending over half of your work shift trying to troubleshoot why the wireless network isn't letting your dozer work, it becomes pretty frustrating. So there's a great example there of how mining companies have used 5G to really change the way they work, drive safety, but also do things that no other wireless technology has allowed them to do previously.
And so, what was the outcome in terms of how efficiently it was done, or the kind of time that they saved?
Well, the project's ongoing. You imagine moving 8.5 million cubic meters is not a small undertaking.
Mm.
So it's still going on. But what we're seeing now is that the bottlenecks in the process have moved. Previously, it was the performance of the dozers pushing earth into position that was the bottleneck. Now the dozer efficiency is so high, the site has to work out how to feed them with the material they need at the rate they need to move them. So the great thing we see here is that timelines are being kept, the dozer operators aren't being responsible for any delays, and what we're seeing is a safer, more conducive work environment, particularly around the workers being able to spend more time in the safety of a seat rather than with the noise and the vibration of a dozer cab.
You've been listening to Ian Ross, Ericsson Head of Enterprise Private Networks, Australia and New Zealand, sharing how on-site private 5G connectivity is allowing miners to unlock a wide range of safety and productivity benefits. To learn more about how private cellular connectivity can aid your organization's digital ambitions and extend your wireless capability, contact Ericsson at cradlepoint.com/about/contact-us.